Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, in previous lecture yesterday we discussed lots about one of the managerial tools used for analysis of data, and that is Excel. And for this we have again with us in our studios Dr. Opivali, who is a professor in IIFT, and under his able guidance and his constant efforts we try to learn about Excel, how Excel helps us in analysis of the data. And today also, continuing from our previous lecture, we are going to learn more from him. So I would like to welcome our guest, Dr. Opivali. Hello sir, welcome to the EduSet lecture, and I would like you to continue more and explain us more what else we can learn from you.
Yeah, sure. Thank you. So as she said that we would pick up things from yesterday. We actually introduced a couple of tools yesterday. The first tool that we introduced was data table, which helps us to analyze data on single variable or two variables. And then we introduced scenario manager, which helps us to scale up to 32 variables. So we had stopped midway because of the paucity of time. Now what I am going to tell you is that while we are using scenario manager, we need to understand one more thing, is that you need to actually present your output to say your senior or peers or say board, whatever be the say context. So it is important that the presentation part is really taken care of. So yesterday, if we go back to the same example that we use of sales price variable cost arriving at the gross profit, we had used this formula to arrive at the final gross profit figure, and then we use the scenario manager by going to the data, by going to the what if analysis, going to the scenario manager and creating one of the scenarios. So I will again create it and show you some more things so that we justify the use of this particular tool. So let us say we say scenario 1, and by changing cells, these three cells, and we arrive at the final scenario and push summary over here. So here is what we get. Now if you look at it, you will actually see that we have changed these three cells over here, which is first one is sales quantity, second one is price, third one is variable cost, and these were the base figures, and this is the scenario that we created. So we have not actually changed any of the figures. We could have really changed, but the important thing is, but if you are showing this output to your peers, to other people in your organization or somebody else, they will not be able to understand these cells. So they have to be shown the original say description of the cells. So to do that, let us go back to the sheet 1 and name the cells. So naming of the cells, naming a particular range is quite important when you are actually using scenario manager. Otherwise your audience will not really understand what is really happening. So we will name this cell. So we will say this is sales in units, and we press enter. So what happened is here sales units. So we have given it the name sales, and you will see now if we press this particular cell, it is B3, but if we go to this particular B1 cell, the name appears over here, so sales units. Similarly, we will name this cell as price, but what you have to remember is when you name a cell, there should be no gap in between the letters that you are using. So we say variable cost, but if we leave a gap, it won't really accept it. Similarly, we name this cell as G profit. So now if we again go back to the scenario manager and press this, and again take these things, again go back here, say now scenario 1, changing these three cells again, it is already mentioned over there. Then we give some values over here, 1200, 11 and 7, and say okay. and push the summary over here and click on the result cell, which is gross profit, the target cell, and say OK. Now here you see the change. That is important. That is what I wanted to really show you, is that in this case now we have the name of the cells actually appearing over here, which is more understandable and more user friendly way of say presenting your output of analytics, whatever analysis you are doing. So that should be really taken care of. So moving forward from the scenario analysis now, as I had told yesterday also in my session, that we will apply simulation to understand more insight from any kind of data that is available to you. So before I actually apply simulation, I think you need to understand various tools which are available in the Excel, which would actually dovetail into the final solution that I would be actually showing you. So various things that you need to know before we really move on to the actual use of simulation is any kind of data that you have, we have two basic tools to understand it, which are quite common across say analytical world and even across academics. Two things that you need to really have, two basic tools. One tool is to understand a single variable, other tool is to understand the relationship between the two variables. When I am saying variable, it means that any process, any event which is influenced by say X number of things, whichever things are really influencing it, if the value of that particular thing is actually changing, we call it a variable. It is in the most simplest way of explanation. So let us say sales. Sales is a variable. Price is a variable. Variable cost is a variable. In fact, gross profit is also a variable dependent on the other three variables which are mentioned above it. So these are three variables. But you can really appreciate that, let us say price. Price is in itself dependent on so many other variables. Price could be dependent on the demand, it could be dependent on the competitor prices, it could be dependent on customer behavior, it could be dependent on so many other factors. So each influence actually can be further articulated into some kind of a variable and subs of variables. So there's a huge set of variables which probably can influence a particular decision situation, but it is important for a decision maker to really get hold of the most important variables to comprehend the thing quickly and analyze the situation. Otherwise, you can have thousands of variables which could actually be figured out for a particular situation. But important thing is the most important variables are always considered, because it becomes easier for the decision maker to get hold of those variables, understand their say linkages, and try to take a decision. And within those variables, there are two things: certain variables which you can actually say influence as a decision maker, which are controlled variables, and certain variables are which you can't really control. Let us say a business person or an entrepreneur may not be able to influence the tax rate which is applied by the state, but they can definitely influence the price. You may not be able to influence the demand from the customer side, because there are a lot of other factors which go into that, but you can definitely influence how much inventory you really maintain, how many distribution channels you really operate through. So those are the important things that have to be considered while we are trying to understand the space of the variables. So having said that, controlled variables, uncontrolled variables, and the influence of the variables in a particular decision making situation. So two important things remain, that is understanding a single variable and understanding the association or the linkages between different variables. So what are the basic tools which are there, and how does really Excel help us? So let us understand it. So if I take this particular sheet, let us say demand. Can I have this Excel sheet? Yeah. Let us say demand. And let me put some figures and say these are the sales for last 12 months. So what I will do is I will use a function which is called rand between. So, and I say, let us say the sales have been between, demand has been between 1,000 and 5,000. So here it is. So I just drag it. So I have different demand figures. These are just hypothetical, random figures that I have really put over here. Now, to really understand this variable, it is important that I should be using some tool to really see what is this data telling me. Is there some kind of a pattern emerging? Can I use some parameters to really explain it? And that is where comes the statistics that I was discussing in my previous session. That statistics is key to, you know, decision making, and the biggest aid that a good system, scientifically approach decision making can really use. So if we look at this data, and now I have to gauge about what kind of behavior it shows. So what I will do is, can I have the Excel on the screen? Yeah. So one way is, if I can go to the insert sheet and just plot it. And something like this, a sheet comes in front of you, and where did it go? So I will just, so we have something like this. Now, if we plot this data, we have actually plotted the individual data points, and each point shows the value of that particular data. But this is not really the desired graphics which will help us to understand this particular data. What we need to really use is a tool called histogram, which is the basic tool which is taught in any statistical course in the most beginning sessions. So one has to really understand how to really draw this, because it is vital to any analytical process that managers can really use to apply scientific methods. So what I will do, I will just delete it and draw a histogram to tell you how to do that. So if we have this data which is from 1000 to 5000, what we need to do is first create the intervals, because this is a continuous data, and we will have, let us say, 1000, and next one, let us create a slab of 1000 plus let us say 50 or 100. So we have 1100, and let me oh, has become much more. Let us keep it more simpler. So I will take, let us say, 500. So that becomes easier. Now, so we have this. So our whole data will be actually lying between two values, 1000 and 5000. And here is our data set which we have created, hypothetical data set. Now if we want to draw a histogram for this data, we'll have to go to data. We'll go to the data analysis, and we will find a tool here called histogram. We just click on it, say OK. It asks for two things, input range and bin range. So what I will do is, I will give the input as this data which I created over here, and then I go to the bin range here, and the bin range means intervals. So I select this interval over here, and then say chart output, okay, and in the new worksheet we can put it there and say OK. So I don't know where it has gone. What happened? I will have to do it afresh. Just a minute. Problem of doing things live. Here it is. New worksheet. I can create and chart output. Okay, here it is. So what has happened is that this tool has helped me to create the the frequencies over here, and here you see the histogram which actually shows you the frequency of values lying between different intervals from 1000 to 1500, 1500 to 2000, and so on and so forth. So how is this histogram useful to help me analyze a particular variable? Now this variable could be demand, this could be cost, or this could be any of the hundreds of variables that can actually influence a particular decision making situation. Now, there are various concepts which people who, whether they read management, they read say technology, they read statistics, they read mathematics. So there's a big subject called probability, which even is taught in 10 and 12 classes. So this histogram is even introduced at that point of time, and we are also introduced to concepts called the parameters. So parameters are the important things that we have to really get hold of and see the relevance of those parameters in analyzing a particular histogram. What that means is this: the histogram shows us that the data is more or less normally distributed. That means there's a congestion of the frequencies towards the center of the data. Then we can actually apply the parameters of average and standard deviation. What it really means is that two parameters can give us the info of entire data set, whether these are millions of data points or whatever number. If we have just two parameters, average and standard deviation, we can actually visualize what is really happening inside the data, provided the data that is available to us is normally distributed. If the data is not normally distributed, like in this case, as you have seen, this data is not normally distributed. This is, randomly distributed data, and this kind of a behavior would be called uniform distribution, because every data point had an equal opportunity of, being in the frequency interval. So that's the first thing that we can actually use Excel for, is plotting a single variable, trying to understand that particular variable. Then we have means to really calculate its average and standard deviation. You can actually get along with histogram those particular parameters, but if you want to calculate it separately, you can actually do it. So is equal to average of this entire data set. So we just do this. Here it is. So you have seen that in just a second we are able to calculate the average of the data, and similarly we can calculate standard deviation. Now if you want to see the formula, very simpler, we have actually used is equal to average of this entire data range. So that gives us the average. So similarly you can calculate the standard deviation. So is equal to STDEV, here it is, and we can again select this entire data range, and here it is. So we have both the parameters in place by simply using two functions, two formulas, and that gives us the entire scenario. So two things have to be really understood is, whenever there is a data set in front of you, you have to actually plot it. So what we call as visual analytics, visualization of the data. Visualization gives us a kind of a smell about, gives us the kind of feel about what this data is all about, whether it can be really, further analyzed through the kind of parameters that can be used, like average and standard deviation. But if the data looks quite haphazard, doesn't have any kind of a proper distribution or a behavior, then these parameters really don't matter, because they can't really explain that particular data. But most of the time, most common distribution across most of the data is the normal distribution, and there are other distributions which may apply. Like a Poisson distribution would apply with the arrival of say things in a particular time interval. So there are a lot of distributions which are relevant to certain kind of situations, but normal distribution is the most commonly used distribution and the most commonly observed behavior. So it can be applied to situations, it can be applied even to the individuals. See, all of us basically display a normal behavior. That means there is a particular behavior through which we can be predicted by others, and if we deviate from that behavior once in a while, then we are behaving normally. But if our behavior cannot be predicted, that suddenly I am getting quite angry, suddenly I am very funny, and suddenly I am very different behavior. Any behavior can't be predicted properly. That means every behavioral aspect, every behavioral possibility can have an equal chance of really being there in a particular interaction situation, then I am abnormal. So that is basically what we call as a normal behavior. Normal behavior means that a particular behavior can be actually predicted. Extreme behaviors may happen once in a while. So that is the common understanding of the normal distribution of normal behavior. Now the second tool that you need to really understand is a very interesting tool, and that really helps us to move our analytics further, is the association between the variables. So how do we use that tool, and how it really helps us, that would be explained later, but for the time being I will just show you what is the tool for the association. So I will delete this entire stuff. Let me do one more thing. Let me say there is this demand 1, and let us say this is competitor's price. Competitor's price, and this is my demand. Let us say competitor price is varies between, let us say, I will show you later how to do it, how to randomize things. So let us say their price varies between 10 and let us say so that we can have an equal number. So let us say it varies between, again, let us say 1000 and let us say 4000 randomly. So this is the competitor price, this is my demand, and so we have two things. We have competitor's price which varies between 1000 and 4000, and this is our demand. So let me freeze it for a moment, and so I copy it, I paste special it, I convert into values. Now this data is frozen, it can't change, otherwise it was randomized. That means every time you click somewhere it will actually change. So there's an interesting tool in Excel, graphic tool, which is called a scatter plot, which will help you to really smell the association between two variables. So we will select this entire range of two variables, go to scatter plot and simply click over here. Now you see this particular scatter has appeared over here. This should give you the kind of feel about is there any kind of association between the two variables. Now it looks quite haphazard kind of scatter. What do you get out of it? So thing is, click any of these points here, and these dots would actually get highlighted. Right click on any of this and press add trend line. The moment we do this, let us see whether there is a linear association between the variables. So display equation, display R square values, and I put a close over here. Now here is what it gives. It gives me an equation. What it tells me is that y, that means y axis, y values, right, which are the price of the competitor versus the demand, which is given in the x-axis, is dependent on, is positively associated with a coefficient of 0.127. Though the relationship is quite smaller, but there's a relationship, and if the relationship would have been quite stronger, you would have got a much higher value of the coefficient. So that is where scatter plot helps us to understand the correlation factor between the two variables and helps us to take the analysis further, believing in or hypothesizing that there is an association between two things, and we can really investigate it more. So these are two basic tools that you should learn before you start applying scientific tools for managerial analysis, because they are they are vital in really helping us doing this whole analysis. Now coming back here, what I need to really tell you is that what I did when I was creating the data, because that is quite important to understand. There are two things that you need to really understand. One is you should have the ability, skill to model a particular say decision situation, and then you should have the ability to bring in the actual behavior of the variables in the model. That is, like in this case, what I have done is I have put sales as a static figure of 1000. I have put price as static figure of 10 and variable cost 7. Yesterday, when we were doing one-way or two-way table data analysis, we changed certain figures. We said the sales could be between 800 to 1500 with some slabs. Price could be between 8 to, let us say, 12 with some, say, intervals. But that may not be the actual behavior of these things. It is quite possible sales may be happening normally. That means there could be an average sale of, let us say, 1000 with a standard deviation, with a variability of around, let us say, let me take this is average. Let us say the variability in data could be, let us say, 300. And similarly, let us say we can keep the price constant. Let us say this variable cost per unit, maybe 7 is average and with a standard deviation of 1. Now what does this mean actually? This means that sales can vary anywhere between, let us say, 200 or 100 and it can go up to 2000, but it will on an average stand around 1000. But if it is normally distributed, let us say, which normally is the case with most of the data, that is the data would 70% of the time, roughly 70% of the time, vary between 700 and 1300. And 95% of the time, the data may vary between, let us say, 400 to 1600. So again, it means if the data is normally distributed, that means there is a roughly around 15% chance that data would actually the demand would be between let's say 400 and 700 on the left side of the distribution, or similarly on the right side of the distribution. So you have to start visualizing the data in terms of the normal distribution, if the data is normally distributed, let us say in this case. Now if the data would be uniformly distributed, then any value can happen any point of time, or if there is any other distribution, so accordingly you will have to really visualize the behavior of that particular variable depending on the type of distribution, because certain distributions there could be peaks towards the end. That means data is going very exponential, like gamblers. As they lose more money, they start putting in more money. So there is an extreme behavior that happens. Similarly, the arrival of vehicles. So there is a lesser chance of having more vehicles in a lesser period of time, more vehicles in higher periods of time. So if we plot it, it will be a different kind of a curve, not a normal distribution. So the data visualization, the parameters, and the decision situation context is quite important to really understand before we start using such kind of tools. Now in this case, now if we have to model it, like we created a simple model yesterday, we have created the equation of the profit. So this profit equation is nothing but the model of the profit, which is dependent on three things: demand, units, price, and the variable cost. But the important thing is, how do we now bring in the variability part of the variables into the model, and then see what is the kind of possibility of the profits that we can really have, rather than simply saying that price could be between 8 or 9 or 10 or 11, or sales could be 1000, 1100 or 1200, because sales could have any kind of a possibility in the given situation. Now imagine if there could be a supply chain which is trying to address the customer order fulfillment of our customers in Dubai, and we are supplying from, let us say, some state in India which has go to the port and then will get dispatched. All this whole process of getting the order and supplying it in a particular time frame and assuring quality within a kind of a cost, a lot of variables come into the play. And if I am if I have to assure my buyer that I need to really supply this material, let us say, in X number of days, and if I want to really model it, work out the least cost that I can really provide that, and work out the maximum cost that can really happen, and I could be in a soup, I can really model this entire chain and can really figure out what possibly could happen, possibilities I mean, the range of possibilities. But important thing is, I need to bring in the behavior of the variables and get the spectrum of outcomes that are possible. So when I say spectrum of outcomes, again there will be huge data points for the possible profit that can really happen, for the possible time that can be actually achieved in the whole delivery process. So how do we really do that? To do that, you need to again understand one basic function or tool which is available in the Excel. Excel has two basic interesting tools, two functions that you can actually use. One is called, both are basically both help us to randomize randomized data. One is called a rand between, other is called rand function. So let me use both these functions. So one is rand between. If I say rand between 100 and let us say 700. No, that would be difficult to understand. I will say 1 to 10. Now what will happen is, it will always generate values between 1 to 10. But please remember, these will be always integers. Now if I press a delete key going outside it, the moment I press a key, it will change the number. So we will always get a value between 1 and 10. So this function doesn't ask for any kind of an value. You simply write the function, it will generate values. Now how we use it, I will show you later. Second function with Excel is which is called a rand function, which is the most important function in analytics or say managerial use of Excel is the rand function. So it is like written like is equal to rand, parenthesis starting and closing. I just press a delete key or F9 anywhere else. I will get a value between 0 and 1. Now this particular value that we have got would be actually consumed in creating that what we call as the actual behavior of the variable that we really want to get into the model. So how we do it? Let us see. So these are the two functions, and the rand between we probably don't use much in the analytical process. We normally use, as a professionals, we use rand function. So we will use it, and I will tell you how. Now let us say I want to create normally distributed say sales, normally distributed. That is based on some historical data I have found while plotting the data, that my demand in this particular territory, demand in this particular segment behaves normally. It has two parameters. That means the average is, let us say, 5,000 and standard deviation is 1,000. Now I want to bring this thing into the model rather than a single value or a couple of say slabs. So how do I do that? So rather than writing 1,000, now I will use a function which is very interesting, and you need to really remember it. Not remember it actually, you need to know, you need to be aware about it, that these are the functions which are available in the Excel, because the moment you write it, it will actually show you what all is required to be, because there is great amount of help in the Excel available to you. So only you need to be aware about these functions, name of the functions, then everything else would be assisted by the application itself. So the function is what we call as norm inverse. Norm inverse is the function written like NORM parenthesis. We have to give rand function as the parameter of probability, give a comma, give the parameter of average, and give the parameter of standard deviation, and close it. The moment we close it and press it, we get a data point. What it means is that if 1,000 is average, 1,000 like this, and standard deviation is 300, what could be the possible values that can happen in a normal distribution? What it means is that if I generate randomly distributed data based on normal distribution, we will have, let us say, all this data. Each data point, if we actually plot it in a histogram, would actually be plotted as a normal distribution. So that is what basically this particular function does. That means with this function you would be able to create the normal behavior of a particular variable by using two things: function norm inverse and the other function rand distribution. Only two parameters you need, which from the data, from the previous historical data, or could be as subject to judgment, is the average and the standard deviation. So this is what this particular function helps us to do. Now to really test whether this actually has worked for you or not, what we can do is we can just freeze this data by copy, paste spatial, and values. Now we have normal distributed data generated hypothetically by us, right, which actually is based on the values of average and standard deviation we had actually calculated. So let us start from, let us say, 200 to 300, and we will take this data up to, let us say, 2000, let us say. Now these are the intervals that I created, and now I can actually again draw the histogram by going to the data analysis and see whether the data I generated is normally distributed or not. So it asks for the input range, so I will give the input range over here. This is my new input range which I created. Then it asks for what you call as the bin range. Here is my bin range, and it asks for the worksheet output. So I will create it over here, chart output, and I will say OK. here you can actually see now the data. If you can look at this data, and you will really appreciate that this data which we generated is actually a bell-shaped curve, is of course closer to very normal distribution. That means the data we have generated is normal distributed based on two things, average 1000 and standard deviation of 300. So that is how we use random function and the norm inverse function to create a randomly distributed, normally distributed data, which we can use further in our modeling and apply the simulation. So I go back here. Now what I will do is, I will create this behavior of based on normal distribution or any other distribution, any other behavior into our model, and then see whether we can actually capture the profit using simulation techniques. So that is why the simulation really helps us. That is, simulation means that we are trying to replicate the actual behavior of the variables in a model, in an equation, and then trying to see the range of possibilities that can happen, and then analyze it. So that means we are not missing on the information. What happens in the traditional analytical tools is that we normally used to have three scenarios: the best scenario, the worst scenario, and the most possible scenarios. What happens in between, we didn't have any kind of an idea. So possibly three possibilities, quite categorical kind of decision situation for us. But the real world is really operating in a very different way. That means there are a range of possibilities which are in between. People may really, it may really matter a lot between losing a 0.5% opportunity in, say, energy sector, which could be turning out into the millions or billions of dollars. So people need to have that information, which is quite minuscule or very hidden between various layers of these intervals and scales. So let us see how we really do it. So first thing is, let us assume that the sales rather than 1000, now as we did, we will assume that this is normally distributed with say random function as the probability parameter, and we take average as, let us say, 1000, and let us say we take standard deviation, let us say 250. So we have created the first variable as normal distributed distribution of the sales demand, or say sales units, and similarly we can, let us say, the price can vary uniformly. If it varies uniformly, we can even use rand between. Rand between, let us say it varies between 8 to 12. So we can have different possibilities of say price, that means 8, 9, 10, 11, 12. Let us say the variable cost is also normally distributed. So I will again use norm inverse and say rand function, and then put a mean. Let us say on an average the variable cost is 7, but the standard deviation, let us say, is 2. Okay, and or I can put it as this one as variable cost at 9, so that we have very interesting numbers later. So here it is. So then I calculate the profit. Profit would be sales multiplied by price minus variable cost. So here is my model. Look, now in this particular case, single case, let me know, this was the earlier case that we did, the base case. Here is, I am including the behavior of the variables. That means if I press a delete key outside, look here, every situation, every scenario is possible now. That means there could be a scenario, sales could be 1294, price could be 12, variable cost could be 8.8, and my profit could be 4118. There could be next scenario, which is also possible, 630, 8 price, 7.7 is the variable cost, and my profit could be only 129. Who knows what actually will happen? So the managers are more concerned about the possibilities, the most probable happenings in the future. So the prediction of what is really going to happen is what is really achieved through this kind of modeling. So the first thing that is required is capture the behavior of the variables based on the historical data. Get the data, plot it, see it, what kind of behavior it shows. Based on that, use the appropriate function from the Excel and include that particular behavior into the variable. Now, having done this, so the challenge remains now, how do we capture the entire range of possibilities for the gross profit? Now, somebody would actually do it like this. Let us say we will put gross profit here, price here, variable cost here, and calculate gross profit here. I can actually write this equation over here, copy this equation for thousands of say rows and calculate the gross profit here. I can do that, and then this D column would be actually the range of the data that we will use, and we will plot that and see how the gross profit will really look like. That is good, valid, but that is not the professional way of doing it. Reason being that in real situations, in business situations, we don't have only 3 variables, and our models don't really stay in one worksheet. We normally have n number of worksheets which are hyperlinked with each other, and all of variables are scattered across various worksheets. So it is important that we have a better way of modeling this thing and creating the range of the data for our target outcome. That is, let us say in this case is profit. In a supply chain context, it could be the time period. In say any other case, it could be the distance covered, the cost, total cost of say process. So depending on the situation, we have to really see what is the target and how the target is linked to various say influences, I mean the variables, and what is the impact of those variables and how they are associated with each other could be another interesting thing to really look at. So that is advanced, we are not going into that. So let us look at this aspect. So what we do is we apply a technique which is called simulation to easily get the entire spectrum of possibilities for the gross profit. So how do we do it? Let us go into another sheet. So I say my gross profit is like this. This is my gross profit. I want to have gross profit here. What I need to do, like I said, you need to simply refer the gross profit cell over here. Here is my gross profit. So I have taken just one scenario and referenced over here. Now I need, let us say I need to have 20,000, 1 million scenarios, so that I get the entire range of possibilities, different prices, different demands, different whatever. What would be the profit? So similarly, like I have taken 430 here, I can take n number, I can take actually 1 million. And you don't have to really spend a pie for that, because Excel can give you the the latest versions. You have innumerable say rows at your disposal. So what I do is, only thing is I select the cell, I take a one cell extra in the left side of this particular cell. I don't have anything in that. I then go across the rows down and select as many as rows I really want to create the number of scenarios. So I have some number of scenarios in my mind. Similarly, accordingly I select the number of rows. Then what I do is I go to the data, I go to the what if analysis, I take this tool again, data table, which you saw yesterday, which was actually used for one variable analysis or one row analysis, one column analysis, or you can at the best use 2 variables. You can change 2 variables. But here the case is that we have n number of variables. By the way, in this case there are 3 variables. It could have been 100 variables, or it could have been 1000 variables. So I don't have to really worry about that part. What I have to do is I simply have to click a cell in the click this column input cell, go to a blank cell here. That is important. You have to click a blank cell and then press OK. The moment I press OK, you will notice that the whole data gets filled up. Look here. Now the whole data has filled up in this column. That means these are all the possibilities that can really happen based on different values of demand, price, and variable cost. So this is our, what we call as we have iterated the data so many times and get all these possible scenarios. So this is what we basically call a Monte Carlo simulation. Meaning thereby we have inducted the behavior of the variables and got the corresponding profit for that by modeling profit based on the influences it is based on. So now if this data is lying in front of you, the question remains, how do we really analyze it? What is the next stage? So I have told you in the beginning that the best way to analyze a single variable, now it becomes a single variable in this case, is that I use histogram. So what I will do is, let me just Control C, paste spatial values, and it is now frozen so that it doesn't change now. I can take these values, and a good practice is that you have more number of rows. If you have, let's say 20,000, 40, 50, 1 lakh rows, the more data you will have, the more accurate estimation of the future you can have, or the prediction can be much better. So that is important. So what I will do is I will look at what is the maximum value of this thing, what is the minimum value achieved, then I will calculate the average of this, and then I will calculate the standard deviation of this whole data range. So what I do is I take is equal to maximum. Here it is. So this is the maximum value of this whole stuff, and I don't know whether it works. Yeah, here it is. So I will actually drop it down, and because I use the same data range for all these calculations, this is the minimum value, and here this is the average value, right, and here this is the standard deviation. Okay, so these are the 4 things that are available to us. The important thing is, first thing that we need to do is look at the histogram of this data. So how do we do that? So let us say what is the interval that we want is, let us create the interval which would be maximum minus minimum, and we want, let us say, 10 intervals. So divided by 10. So my interval is 1585 point this thing. So what I will do is, I will start with my minimum value. This is my first value. Then I will add my interval to that. So D7 would be held constant. Here it is. So I will just up to my maximum value. My maximum value is how much? 8613. So I will go over here, 8613. So these are my intervals. Now based on these intervals, let me calculate, look at the histogram and see whether average and standard deviation really makes some sense. So what I do is, I go to the data analysis, I take the histogram, I know it asks for the data input range, so I will take this entire gross profit stuff and I will go to the bin range. In the bin range, what I do is, I take this one, and in the output, let me make a safe place here, and I say okay. Here it is, and here is the profit histogram. Now you see, if you look at this profit, quite interestingly, you will see that the profit is actually a normally distributed chart, and when it is normally distributed, parameters become relevant, parameters of average and standard deviation. Now you can explain this data with the help of average and standard deviation. If this data would have not been a normal distribution, then there is there's a lot of issue with really using these parameters. So you can't explain it with the help of standard deviation and average. So let us now go back and see how we can now explain this data more better with the help of average and standard deviation, given that it is normally distributed. So what we do is, we will again now look at some more functions which help us to explain a lot of things. So average and standard deviation becomes much more relevant in this case. So I will just create some more space for myself. So let us say I want to now understand what is the possibility that I will actually be making a profit. So given whatever data I have got about the gross profit, so the first question that I can clearly ask myself, is there a possibility of a profit, and if it is there, what is the the quantum of that possibility? So how do we do that? We use again functions which are available in the Excel, which is called norm distribution, norm dist, and we want to say whether we can actually make a profit. So I will give the first parameter as 0, and then I take mean is average is this, then I take standard deviation, and then I want cumulative as 1, here it is, and 0.35. So what it basically says is, it calculates the cumulative distribution from the left side of the normal distribution from the curve, which is a bell-shaped curve, up to that point, which is the parameter that I have given in the beginning of this function, that is 0. That is, what is the possibility of achieving 0 or less than 0 is 35. So what is the possibility of making a profit? Is 1 minus 0.35. So the possibility of making a profit is roughly 65%. And what is the possibility of breaking even is, you can have or making a loss is 35%. So that is where this particular function is a great tool in analyzing data, provided two things. If we go back, there are parameters which are calculated, and these parameters are relevant to the kind of behavior profit behavior actually shows. That means there is a normal behavior. If there is no normal behavior, these parameters are useless. So and how did you really get the profit? Profit you got based on the spectrum of values that were actually generated based on the different values that different input variables can actually occur. That means demand, price, variable cost. So whatever variables are actually influencing the final outcome, you have to really get that behavior in place. But many times it happens is that we don't have any idea about the previous historical behavior of a particular variable. A new variable comes into the picture. So what do we do? So you can actually get the use of the experts up to the most likely say value, least likely value, or the you can actually have a subjective judgment on that based on some expert opinion. So that is where we can we will say that this is a subjective probability or subjective behavior assigned to a particular variable. But in case of historical data, previous data is excellent because it is more closer to the possibilities that can happen in the future. So the basic assumption here is what has happened in the past regarding particular variable that is likely to happen in the future. So that is the basic assumption we are carrying along in this whole analysis. And we are also assuming certain things in this particular model particularly, that things are going to really happen linearly. That is there won't be much deviation on say either side, right or left, or say up and down, the way things are happening in the past in terms of the association that is happening between different variables which are accumulating or dovetailing into the final equation. So we have to really understand and be aware of that say assumption. Now what could be the interesting part in this whole modeling? Interesting part could be, let us say in this case we just use 3 variables. Let us say there would have been a situation, there would have been 100 variables. Let us say supply chain, and I want to really see what are the variables which are actually influencing my final outcome, so that I can really achieve some efficiency, where I need to really focus, make some improvements, because this is the problem of most of the organizations. They are competing in the market field. So what they have to do, they have to every day find new ways of really improving, either cutting down on the cost, innovating in the process to deliver more satisfaction of the customers. So idea is, can these models really help us to really arrive at those most vital say ingredients or influences which could be really worked upon to achieve some more efficiency. So how do we really do that? Let us say in this case I could really work out the probability of cost. So probability of cost, let us say, is loss, is let us say 40%. So my target, let us say, remains in the next 6 months I want to bring down the probability of loss from 40% to let us say 20% or 10%. Where I will get this 10% level, say efficiency factor? How do I do that? So I have, let us say, 20, 30, 100 variables which are actually modeled in the equation to create that final outcome. So I need to really get hold of the most important major variables, input variables, which have a high influence on the final outcome. And I am least interested in the variables which hardly have any final, say, no impact on the final outcome, though they may be influencing, but the influence may be quite smaller. So the first thing, the initial periods. So I would be interested in the most obvious influential variables. So how do I really do that? So what I probably need to do is, rather than simulating on only the profit, I will, along with the profit figures, I will also simulate the input variables. That means here in this case, what I have done is, if you look here, I have only brought the profit over here. I have simulated the profit. So what I can do is, I can actually simulate various input variables along with that. So gross profit is here. I could put in, let us say, demand figure here. I could put in another variable over here. So I can, plot 10 variables along with the final variable, target variable, and simulate all. Only thing I need to really take care is that I need to keep one blank column on the extreme left side and follow the same process. But once that is done, the important thing is that how do we really find the most vital and important influences in my, say, on the final target variable. So what I will use is, as I showed you in the beginning, is the scatter plot or correlation concept, which helps us to really see how correlated are different variables across each other. So I will correlate the final variable, that is gross profit, with all the variables that are captured along with that. That means different scenarios of demand, different scenarios of profit, different scenarios of cost, different scenarios of price, and I trying to really cross correlate. The correlation factor, if it is high, significant, accordingly the influences are quite high. So this is the most simplest and the basic way of really approaching any kind of analysis, and it also helps us to gauge the amount of risk that is associated with any kind of decision situation. There is where you can use a norm dist kind of an function, because it helps you to assess the probabilities of, like I said, what is the probability of making a loss, what is the probability of making a profit. So you can actually pinpoint or narrow down on, say, smaller issues and work out those possibilities that can possibly happen, and then probably have the execution procedure followed after that. So that is the kind of agenda that I was having, to give you the basic framework of analytical decision making, use of Excel, because Excel is fairly accessible to most of the people here, because Microsoft being so common and ubiquitous kind of an application. And once you get started, the idea is that you have to really keep working on it. You will have a lot of features, a lot of nuances while you are actually applying this application. But thing is, somehow if you get started, you will really enjoy it. It's an exciting area to really work on. So that was, in fact, I thought it could be a good starter.
Definitely, so it could be a very good option for one who is more into the analysis or research kind of thing. But what are the chances of error, if you talk about? Are there any?
See, because this is based on simply logic and
all calculated
mathematics. So the errors can't possibly happen, because these applications go through a lot of feedback and improvisation. Errors or start in any kind of an application. No software is particularly perfect. No modeling tool is perfect in the beginning. So they are improvised over a period of time. That is why there are versions and versions that keep on coming. Or there could be gaps in the in terms of creating a complete solution for the user. But yes, I will tell you one thing. There is a problem with Excel. Excel is basically meant for smaller kind of, say, data sets. If you are really very keen to develop yourself in the area of, say, simulation based modeling, then one needs to really use proper applications for that, which can actually handle say billions of iterations and innumerable number of variables. And if you have data which is lying in your server, it can get integrated to that, and it can be on the internet, it can be anywhere in a remote location. For that you need proper applications. Like I will give you names like Crystal Ball, At Risk, Simulate. They are the kind of applications. They are costly. There's a huge cost for that, but thing is, they are actually used by the companies who are very much into the simulation, like energy companies. They have to do a lot of simulation exercises to actually go, before they go for the bids. Let us say I have to bid for the reserves in a particular country. I need to simulate on the partial data that is available to me to work out what are the possibilities of getting the amount of reserve in a particular, say, mine or sea or whatever. So simulation is very much a kind of a practice among these companies, but they actually use such applications, because Excel, you must have really seen while I was doing it, I was constantly converting the formulas into the values, random numbers into values. The problem is that Excel will hang. Its ability is very limited in terms of handling large data. So that is an issue.
Thank you, sir. Thank you so very much for making us aware and giving us deep insight into this very software or very topic. I would say thank you so very much, and in future also we would be conducting such lectures so that the students who might watch us regularly would be benefited. Thank you, sir. Thank you so very much.